we've been talking about the big debate between synthetic turf and natural turf for a long time, and honestly, I'm not here to talk about that, but it's just been going on for an extremely long time, and there are obviously pluses and minuses, positives and negatives that go along with having either surface. But when you start to look at some of the articles that come up, comments that come up, there really is no regard for whether the fields are real or synthetic. It's really just, people taking note of the fact people taking note of the fact that there's some issues with the playability of the turf. Again, regardless of whether it's real or synthetic, just a couple of headings here from various articles when you do a quick Google search. More recently, though, we've had, sort of a little debate that's gone on just a couple weeks ago at the NFC wildcard game, where I always love when media come up with these random terms that you really don't understand. I don't know what a, slick field is, but, at one point, I believe the announcer kept calling it greasy. I don't really know what that means, but just kind of throwing out the fact that the media really doesn't understand turfgrass, whether it's real or synthetic, nor the management that goes into actually managing these fields. And it's their job to dramatize, embellish, really just kind of, create a story, especially if you have a game that's going on that isn't really that entertaining and they need to really figure out something to talk about, they will pick on the field. And a lot of it goes back to the fact that we need to start educating a lot of the coaches, players, administration, media, and even the public about what it is that you guys do and how much it takes to actually do your job. And I always, laugh at the conversations I have with people on an airplane when they sit down next to me, ask me what I do, and I talk about turfgrass, and the person they always go to is obviously golf courses and how we pollute and so on and so forth. But they don't really understand how much it takes to be a turfgrass manager. It's not just getting on a mower and mowing. There's a whole lot more involved in the science aspect of it. So again, we tend to be the first people to blame when there's a poor performance, yet we seem to be last in line when it comes to monetary inputs in order for us to do our jobs efficiently and productively. So again, the debate between artificial and natural turf, neither obviously are management free. Each of them has their challenges, but both exhibit field variability, and that's what we're going to talk about here in a second. Injuries occur on either surface, but the focus again needs to be on player safety and field playability, regardless of the surface that you're actually utilizing. Today, I'm specifically going to talk about natural turfgrass sports fields. Some of this can be applied to synthetic systems, some can't for obvious reasons. But again, the focus really needs to be on player safety and field playability. Again, just going to allude to an article that came out, which was referencing a report that came from the Concussion Legacy Foundation, talking about the number of head injuries that occur when people are coming into contact with playing surfaces. This was specifically with synthetic turf, but when you talk to people that are trainers, doctors, they tend to tell you that there's no real difference between real and synthetic turf injuries that are out there as far as the numbers. The severity, I'm not really too sure of, but again, the numbers occur regardless of the field type. So variability tends to be the biggest challenge that we have to understanding the field conditions, and I think that's something that tends to be lost on a lot of people. Just to give you a basic definition, variability occurs when there's a measured quantity that's different across both a field and between fields at the same location, or between locations you may have multiple facilities. And just a quick example here. Does not work. Looking at that square, that is a field. We are measuring soil moisture, and you can see that the soil moisture on the field is not uniform, and that can occur for various reasons. It can be the irrigation system. It could be issues with soil compaction in certain areas. It could be issues with localized dry spot, various other things. But just looking at how the soil moisture profile of that site is variable is an important thing to note. So first thing I want to drive home is how all of these plant and soil parameters are interconnected. So we've done a lot, and I say we, predominantly the man to my left here, has done a lot of work where we have gone in and intensively sampled athletic fields for various characteristics: soil moisture, compaction, turfgrass quality, through NDVI, surface hardness. We've looked at the amount of thatch accumulation that's occurring in that field. And then, which I think is the most important aspect, is the root mass. We've looked at rooting depth in the surface, and then also rooting depth deeper in the soil profile. And all the measurements that we took off of this field, and I'll get into how this comes into play later on in the talk, is all based off of the irrigation system that field has. So if there's any imperfections in that irrigation system, that will have an impact on the data that we generated from here. But again, I'll talk about how that works a little later on. So not to get into a whole lot of data, what this is a graph depicting the interactions between a lot of these variables. You can see soil moisture, compaction, hardness, all kind of on that angle there. And it's really just looking at the relationships, whether they're strong or weak, and whether they're positive or negative. And the thing I want to point out is that there's a lot of strong, significant relationships here between a lot of these properties. So they play off of one another, and they can actually affect lots of things going on in the system, and you have to be aware of that. So just to kind of give you a quick example here, this is looking at the spatial variability of this specific field with regard to soil moisture. I'm not going to get into the differences as far as the ranges, but soil moisture on the left, soil compaction on the right. And you can see if you kind of zoom in some areas, you have an area on the left of soil moisture in that little red circle that you have low soil moisture, the lighter green color, and that equates to having higher soil compaction on the right. Sometimes those two things don't match up because there's something else that's going on that has created a different situation. And again, we'll get into that later. So really it all boils down to variability. You're going to have variability on your fields regardless of the field age, the construction, the sport that you're playing, whether it's played on your fields, the level of competition, whether it's little children, whether it's professionals, and there's various other things you can look at, but you're always going to have variability. You can't change variability, and we'll talk about, how that impacts your decisions. And just again, reiterating the fact that you have plant soil parameters, tons of them that are going on, more than we've even measured, that have a major influence on one another. And again, the variability cannot be controlled, but you have to go out there and you have to manage your system. You have to account for the variability when you go out there and come up with different decisions. And the biggest thing you can do, the most important thing you can do, is to try to gather as much information about your site as possible. Whenever I do a site visit somewhere, I never step on that site and assume I know more than the person that manages it, because you've probably been there several years. You know the ins and outs of different things. I'm just walking in off the street. I don't know anything. So you want to gather as much information as possible about your site, and then it allows you to make more management decisions that are based on more information. So disregarding variability, I like to always boil things down to the root system. Sometimes there's a lot of other things involved. But if you disregard the variability, it's really easy to come into a location and look around and see areas where you have open turf. That doesn't necessarily happen a lot in collegiate athletics and professionals. When I go watch my kids play soccer, I'm amazed at the actual facilities they play on and that they can survive the game. But it's pretty easy for me to point out an open area of turf, and you know that that's a problem area you need to fix. But it's harder when you start to deal with things like the root system here, where you have imperfections in the root system that you don't necessarily know are there, but you can actually manage them by actually managing your field using knowledge about the variability of various things like soil moisture, compaction, surface hardness, and various other things. So if you disregard the variability, you really affect the playability, performance, and then predictability. How is your field going to perform? You don't want to be the guy who has a field that's on television and all of a sudden turf gets ripped up for various reasons, because again, the media becomes sort of your enemy at that point. So this all goes back to performance testing. So we link performance testing to player safety, and Chase will talk about that again later on today at 3:30. And we go into performance tests to identify variability of various things. And there's a lot more things than we put on here, but we like to focus on soil compaction, moisture, surface hardness, that compaction in the upper surface, surface evenness, sod strength, and root mass and depth. Yes, ma'am. Yes.
What field is overseeded? but none of the performance testing stuff we're talking about in the next talk. I'll talk about that.
So background in Georgia, we don't have anything that's played. We've had a couple of facilities try zoysia grasses, but it's predominantly all Bermuda grass, and it can be anything from commons to hybrids, various different cultivars of hybrids. So there's a lot of differences in performance because of the cultivars we're using, a common versus a hybrid, but predominantly, I'd say we're 99.9% Bermuda grass. All of this stuff can be applied to any grass you have, whether it's Kentucky bluegrass or something else that you're utilizing. So again, when you look at player safety, there's no way you can prevent all field-related injuries. It's just impossible. But you want to try to do your best to produce a uniform, predictable playing surface. And my predecessor, Bob Carroll, always said it boils down to due diligence. You want to make sure that you're out there, you're trying to produce, the highest playability as far as the field as you can. And as long as you're actually doing that, you've done your job. You're trying to alleviate issues like you see here on this field. And I only put this up here because I'm a Redskins fan. I won't get into the depression I have about RG3 either. So moving into performance testing, there's a lot of challenges that you're going to face and that we face when we do this work. So, what do you test for? What types of sensors do you need? Maybe what sensors do you not need? What are some of the limitations when you use them? We'll talk about mobile versus handheld sensors. How many samples do you take? That's always kind of a debate, and we've done a lot of research on that. How many samples do you need to take to accurately describe what's going on in your field? Irrigation systems play a huge role in your field because soil moisture has such an impact on everything else that's going on. If you have an irrigation system that doesn't work right, then the data that you're collecting is not going to be very accurate. So you need to make sure that your irrigation system is dialed in, and we'll talk about that as well. When, how often do you sample? There's some debate there, and we'll talk about how when you irrigate, how that affects the data that you generate. When you take samples after irrigation events, and how does a dry down from an irrigation event actually affect some of the data that you're generating? And then finally, what do you do with this information? You've gathered some information, whether it's a one-time thing, whether it's every week, whether it's monthly. What do you actually do with this information? So moving into sensor technology, how many people here use sensors? Does anybody use any sensor? Got one person, a couple people. Anyone use soil moisture meters? Anybody use clay impact testers? Anybody have moisture meters inside their facility, in their field? We're doing some things. Lots of sensors out there. Obviously, the first one I would talk about is GPS. We use GPS on most of our sensors. A lot of these sensors are becoming more affordable. I think when we first started using some of the one sensor that has definitely decreased in price and is more affordable is definitely a TDR probe for soil moisture. On the golf side of things, I don't know many superintendents that don't have a soil moisture probe, and it's probably becoming the same way with athletic fields. Penetrometer is basically giving you soil compaction readings. Clay impact tester for surface hardness. Shear vane, which some of you may or may not be familiar with, we'll go over that real quick, is looking at shear strength or the sod tensile strength. Electroconductivity soil meters for soil salinity and soil texture. Again, we've done a lot of research in there as well. NDVI, which gives you some useful information. There's some limitations there because it's hard to tell exactly what information you're getting from that. And then a lot of people are also using infrared thermometers. We do a lot of work with infrared devices on drones. That's becoming a lot more popular as well. So just some basics on some of these, if you're not familiar with them. Looking at a TDR probe, which measures soil moisture, usually from a depth of 1.5 to 8 inches. It'll vary based on the times that you put on the device. Again, you want to try to be as uniform, and I'll talk about how this is affected later too, when you sample. I mean, it's not like you can run out to a field and just kind of jab this thing sporadically. You need to make sure that you're pretty consistent on how you operate the device. You want to record, this records it as percent volumetric water content, so how much of that pore space within the soil profile is occupied by water. They are now GPS compatible, so you can actually get data from this, download it. You can get ArcMap relatively cheap now. It's affordable. It's a couple $100.
There are free softwares.
True. There's versions that are lower level that you can get that are free as well. And you can actually create maps from this very easily. And we'll kind of show you how you do that with an irrigation system later on. Soil compaction. There's quite a few devices out there, some that are better than others. And I'll talk about the limitations to some of these devices as handheld units here in a second. Basically, you're determining soil compaction in the upper 18 inches. Again, depends on how far you go down, the type of probe that's attached, and the device you're using. It kind of gives you an idea of infiltration rates and a few other things reported in pounds per square inch. Surface hardness, most of you are probably familiar with these devices, plague impact tester. There's a few other devices you can use to measure surface hardness. Really determining surface hardness in the upper 2 inches. Now the soil profile, which is extremely important with water infiltration, root mass, root depth, things like that, recorded in gravities. Shear strength, which Chase has used and incorporated a lot in some of the work that he's done, measuring rotational strength of the turfgrass in Newton meters. Really it's trying to give you an idea of the ability of an athlete to make certain maneuvers. You know, how well can their cleats grip the field, how well or how easy is it for them to cut and move direction, how well does that turfgrass stand up to the playability of some of these athletes. Yes, sir.
We've only used the middle part. We didn't really play around with that device a lot because it's really correlated with moisture. So it represents something, but we don't really know what it represents yet. So it's sort of just a generalized measurement that we're trying to get with some kind of data to have some kind of shear strength. But we haven't messed around with the cleats. We just use the metal one. No, we're collecting too many points for that, so that's just, it's hard to carry that thing around, yeah. Yeah, and we'll talk a lot about the sampling here in a minute. We collect a lot of samples, so it's just too much to carry around.
The issue we have, too, with the cleats is that there's, you know, John Sorokin's group at Tennessee has shown that there's such variability between the cleat type that, I mean, it would be, we would have to take additional data using multiple cleats. Because if we chose the wrong cleat, it could generate a data that was either positive or negative depending upon what we chose. So we just go with the, you know, the typical device. But yeah, we'll show you a couple of things that we don't get good R-squared values on too. So plant health. So I do like the fact that people use NDVI meters. What this actually generates, I honestly couldn't tell you. Myself and Dave McCall do a lot of research together. He's at Virginia Tech. And NDVI meters are really supposed to give you an idea of the plant health. When things kind of go awry in turfgrass plants, one of the first things that happens is you start to get degradation of chlorophyll and various other things. With an NDVI meter, you don't really know if the reason behind the plant's not being healthy is, you know, grub feeding, compaction, heat stress. There's so many things that impact this NDVI reading that it can give you an idea of where things are going wrong, but not why they're going wrong. So everything we talked to you about today does not eliminate you getting on the field and actually ground truthing everything. It just gives you, you know, an idea of where things may not be perfect and where they are better. And allows you to focus your efforts on those areas where you have issues. Again, you can't do sort of drive-by field management. You can't sit in the truck and look at the field and be like, everything looks great. You kind of have to still get out there. I know everyone here does, but so these devices don't eliminate you getting on the ground. Color meters are also some things that people like to use a lot of times to give an idea of you know, whether they feel like they need a fertility application because the turf is too chlorotic or some other things. Again, there's going to be differences here based on the types of cultivars you use. Our newest release from University of Georgia, Tip Tuff, is a lighter green color. So it's going to give you a lower color meter, but you're not really going to be able to green it up anymore. So there's some differences there as well that you have to know. So that moves into mobile sensor technology. When I first started doing a lot of this work, I was really only utilizing the upper left device, and I've kind of moved on to several different types of devices with various companies, which makes me feel even more comfortable about the future of this technology. But again, there are limitations to some of these devices as well, whether or not you can afford them. Has anyone ever had a mobile device, whatever it is, come to their facility and give them data? Whether it's a drone or something else. Nobody's ever used a mobile device. We got 3 people, 4 people. All right. A lot of times there's limitations simply because there's not enough devices. A lot of times there's limitations just simply because you can't afford to have some of these devices. I mean, there's a lot of limitations with mobile devices. However, the accuracy of the data that's accumulated is a lot higher, and you can take a whole lot more samples with something than when you do things handheld. And a lot of them you can take multiple measurements at the same time. And I usually show slides. I did a lot of spatial work when I was a PhD student, and I had a advisor that didn't really care how many devices I used, so I used to pretend like I was a pack mule and throw them on my back. And I sampled multiple golf courses looking at spatial relationships of soil moisture, compaction, and various other things. And it took me almost a month in time when I went back and calculated it to actually take all those measurements with handheld devices. So it's a lot of effort and a lot of manpower when you do a lot of this. Chase has done a lot of work comparing handheld and mobile devices, just trying to see, look, are these correlated? And we've gotten strong correlations from everything except for soil compaction. And it really boils down with soil compaction with a penetrometer that you have to be very precise at how you use this type of equipment. It has to go in, what is it, an inch per second? Is that right? I could be wrong. But when you look at some of these mobile devices, there's hundreds of thousands, if not millions of dollars of engineering that have gone into making these devices work accurately. And to equate that to you just jabbing a probe in the ground, it's not going to be the same thing. You don't generate the same data. And I apologize, Felipe, I don't have the R squared on here, but I want to say our R squared is pretty low for comparison.
Yeah, for the compaction, but the other ones are.
Yeah, the other ones are actually very high.
We didn't do the traction devices.
Yeah, as far as I know right now, there's no mobile traction device. So just kind of getting into some of the historical testing procedures, not going to get hung up on this, but just kind of, look into how things have been done in the past. And a lot of this is going to differ based on sport, but you have situations where you take a limited number of samples, you focus on areas that you know are predominantly going to be bad, for lack of a better phrase, versus areas that you'll probably have that are really good, and you try to come up with an idea of how this field is performing. And for this specific example, there's only 5 samples taken on this soccer field, which again, I'll get into why that's just not enough information. When you move into the ASTM 1936 procedure, again, this is football. You see that the number of samples has doubled to 10. Again, you're focusing on areas where you know you're going to have some issues down the center of the field, areas where you may have more or increased playability of the field. It's not as negative as some of the other areas. Again, this is looking at 10 clay readings to give you an idea of the overall surface hardness of this field. The issue we have with this is that, and again, that can jump up to 12, but are less than 12 locations enough? This sort of assumes a specific pattern of wear, and you sort of don't take into consideration what else is going on in the field. And, just to kind of dumb this down, I mean, if you came through this field and, you took 10 readings throughout this field, and you're trying to come up with an average that's maybe less than 100 here for clay reading, and if you average all of these locations, you get an average of 85, which technically tells you that this field is safe. But the problem is that you have other areas that were over the 100 limit that are not safe. And, you're sort of disregarding the fact that there are certain positions on this field, certain areas on this field that are not actually quote unquote safe compared to others. There are some areas that actually you can have readings that are so low that they're actually not safe as well. But again, coming in and taking 10 readings and coming up with an average is sort of completely disregarding the variability that's occurring on the field. Yes, sir. I'm not 100% sure on that.
No, you're right. You're right. Each individual area is, I think, put into like a column. You have a value for each. But just in general, just an overall performance, typically from people we've talked to, I'm sure other people do it differently. This procedure is actually not even for the CLEG. It's actually written for the A-hammer. But this is just a test procedure that's adopted. This is just an example of just a minimal amount of test procedures. But yes, you're right. People do average it. People do look at individual areas. But in general, there's really just not a consensus on how it's done.
Yeah, I'm not focusing 100% on professional fields either. I mean, there are, sure, yeah, but I mean, this is just an example. I mean, and again, completely just an example.
And that's one of the problems is there's just so many different test methods, and we're going to talk a little bit more about it.
I mean, I've spoken with field managers who will take all 10 tests in the same spot. So, I mean, and that's not common, but they just don't believe in the system either. When you get to the high school level, half of these guys don't even know what a CLEG hammer is. So, I mean, we do a lot of our work at the community sports level simply because for us to do all of our work on a professional field that may even get resurfaced every year, it's pointless. I'm not going to see as much of an impact. If I go to the high school level, you know, junior high, all the way down to middle school or to elementary school, you know, those are the fields that could utilize a lot of this work. This is just us, probably in a bad way, giving you as a general example to kind of show you how variability plays into the whole system. Thank you for bringing that up. So that kind of brings us to how many samples are needed to accurately depict field performance. And Chase did a lot of this work earlier during his master's degree, and we probably showed you similar slides, so I'm going to boil this down to 2 slides. But so if you went out there and you took, and again, this is more than some people take, 36 samples versus 115 versus 450, I mean, there's a huge difference in the intensity of the number of samples that you're taking. And just to kind of show you, 450 is overkill. This is a map, again, of looking at soil moisture. And you can see as you go from 450 to 115, the mean is pretty much the same. The mean is going to be the same for 36 samples. You're not losing any interpretation, depiction of the variability dropping from 450 to 115 samples. But once you drop down to 36 samples, you can see that you know, you're not actually describing variability accurately with only 36 samples with respect to soil moisture. It varies depending upon the actual parameter that you're measuring. But again, the mean is going to be around the same. The means don't really change until you get down to single digits. And even then, it's not even that great.
It's not that different. Yeah.
So again, we're just really trying to drive home the fact that you just can't take an average of the field. You need to get more data points to really understand the variability and the performance that's occurring on a smaller scale. I'm not talking about inches. I'm talking about, you know, just smaller regions within the field. So how does soil moisture influence your data collection? So this is looking at, you know, if you were to get a rainfall event, which for the most part is somewhat a uniform application of water, versus utilizing your irrigation system, what's the difference in the data that's generated with the two? And you can see here right off the bat that looking at percent volumetric water content, the variability and the range is quite different when you look at water or soil moisture generated from rainfall event versus soil moisture generated from the irrigation event. And how does that impact some of your other measurements? So we're just looking at compaction here, whether it's soil compaction deeper in the profile or surface hardness. And you can see that for the most part, the surface hardness is somewhat similar. You get a little bit more detail when you have a rainfall event because the application is more uniform. But again, for the most part, the pattern is pretty similar between a rainfall event and the irrigation. It's only when you look at soil compaction deeper in the profile that the irrigation event, you're starting to get numbers that show more soil compaction. The distribution's a little different, whereas with the rainfall event, you're actually getting lower penetration resistance numbers, less soil compaction, and the variability there is a little different. So it all boils down to your irrigation system. I alluded to that earlier in the program. This is at the high school level. Some of these guys that we run into are managing multiple fields, and it's not just the high school football field. We've got one guy that manages all the high school fields, some of the elementary fields, and one of the large parks, in town. And he's got maybe 2 people and hardly any equipment. So it's hard to get out there everywhere to figure out what's working, what's not working. But again, if you can determine that you have issues with your irrigation system and alleviate them, you can do a lot more for your field just by alleviating those issues. So kind of moving into improving the efficiency of your irrigation system. And everyone is probably familiar with the catch can method. It's pretty exhausting to try and conduct one of these. Basically, what you're doing is you're assessing, your uniformity, over your field. You're not really getting an idea or an indication of how effective your irrigation system is, and we'll kind of go into what that means here in a second. So just simply to show this, these 6 dots here are a section of your field where you have irrigation heads. You come out, you place cans sort of equidistant from one another. You want to try to make sure you have some things out there that aren't going to fall over when you turn the irrigation system on, not too high, not too short. And you turn the system on like you normally would for a typical irrigation event that you would conduct. And then you catch the material and you try to determine irrigation uniformity that way. I'm not going to go into how that process works. But really what it boils down to is that there's a lot of things that are involved in the fate of the irrigation that hits the surface. You may have a decent amount of thatch that's in the profile. Obviously, your rooting structure, the depth, and biomass is going to affect movement of water through the profile. Most of you, hopefully all of you at some point, are conducting aerification. You're going to have newer aerification vents. You're going to have older ones. All these things are going to play into water infiltration patterns. You may have a bunch of earthworm activity. I could sit here and go on for days. All the different things that play into the fate of your irrigation. So when you make an irrigation event, it's not like this material is going to move through the soil at a uniform rate and speed, which would be what mass flow depicts. It's like college students on campus. You can make a path for them to walk on, but if their class is over there, they're going to walk straight through the grass. It's the path of least resistance. So the water is going to infiltrate wherever it can get through quicker and easier, and that's going to create issues, with your system. You're never going to get things perfect, but again, if you can figure out why the water is infiltrating more here and less there, maybe it has something to do with your irrigation system, maybe it doesn't. But using a soil moisture meter is going to give you a lot more important data than doing a catch can method, because you're going to be able to understand where you have water infiltration and where you don't, what the re-wetting potential is. You can identify areas of soil compaction. So if you know where you have areas of poor infiltration, you can go out and test for compaction. Maybe there's an issue there with, increased thatch or various other things. You can also, and I'll kind of allude to this at the end of the talk, use a lot of this for wetting agent applications. And we can do site-specific wetting agent applications with some of the new technology we have with sprayers right now. You can also use it for syringing and various other things. But just so I can give you an R-squared value there, Felipe. This is comparing soil moisture efficiency and catch can. You can see that, yes, there's kind of a trend and a pattern, but this is more like a shotgun blast. And for those of you that aren't familiar with R-squared values, something that's less than 0.2 is not really good. So they're not really generating the same information. There's some similarities and patterns, which I can show you here, but there's also some dissimilarities. So there can be some areas where you get a certain idea that, okay, there's something wrong with this irrigation head. You're getting a lot of water right around the head, and there's dry areas around it. And then there may be some other areas where the patterns aren't exactly the same. So again, this is giving you an idea of the functionality of your system, the efficiency of your system with respect to soil moisture, re-wetting of the soil profile, as opposed to, really just measuring where the water hits and where it doesn't. Again, you can get valuable information from that catch can map on the right. I can pinpoint that one head is not functioning properly, but there's some other things that you can't get from the catch can method that you can from the soil moisture method. So really just trying to reiterate again, it's really important to dial in your system because of the fact that soil moisture is so aligned with some of these other variables. It has a huge impact on compaction, hardness, turfgrass health, that you need to make sure that you're providing accurate soil moisture applications or irrigation applications, because that has that long-lasting effect, again, on various other parameters. So we show this slide a lot. I mean, just lots of things that you can use some of these maps for. Maybe your scheduling's off. Maybe you have localized dry spot in certain areas. We come into lots of situations where, again, in the heat of the moment and having to get things done, people put the wrong nozzles in, or they put a completely different head in, and you just don't notice it until, sometimes patterns arise, and sometimes they don't. Some things that you can't kind of see with the naked eye. There's been different spacing. We've had some issues on fields where extra heads were in the end zone for some odd reason, and it just kept making the end zone extremely wet. So there's lots of different things that you can detect with some of these maps that can help you improve the efficiency of your system. Where am I at on time? So what's the influence of sampling time on some of your data collection? This is some work that Chase did looking at a dry down, and you can get a lot of information from this, and he's going to allude to some of this later in his other talk on how you can sort of use this data to set up your field to have the characteristics as close as possible to what you want for when you have a game. I'm just going to allude to the fact that this, when you actually sample based on when you irrigate, it can have a major impact on the type of data you get back. So this is a project where we looked at soil moisture, compaction, turf quality, surface hardness, and traction. What this is a 5-day dry down, looking at how volumetric water content, soil compaction, and plant health change over that 5-day period. You irrigate at day 1, and then you take samples at day 1, 3, and 5. And just to kind of move along with this, obviously, it's going to dry out. So you're losing 34% of your water, but you're also increasing compaction, soil compaction by 25%. Kind of a no-brainer as well. NDVI, obviously, is going to stay sort of constant until maybe if you dry down 10, 15, 20 days, obviously your health is going to go down, but it's going to stay relatively constant. But again, it's important to note that you're gaining 25% compaction after 5 days following an irrigation event. Looking at surface hardness and shear strength, we only tested these on day 1 and day 5, just due to the load of taking that many data samples. And you can see that, surface hardness increases by 15%, and shear strength decreases by 12%. So you're gaining more surface hardness, and you're losing that ability of athletes to be able to cut and make actual movements and get grip on the field. So again, Chase is going to talk more about this and how it affects athletes and how you can use that to dial things in on your field later on. But I'm just alluding to the fact that it's going to affect the data that you generate.
General practice, yeah. And it's important to know that was a sand field too, so a native soil field would even be more drastic as it dries down.
Most people in here probably have sand fields. We deal a lot with native push-up fields. We deal a lot with sandcap fields. We deal with a lot of scenarios that aren't ideal, and we try to generate data from all, just because we know that not every field is going to be the same. They're not going to perform the same. So, but most of the data we're showing here are on either native soil or sand. I always like to try to throw out some low-tech stuff just because some people don't like technology. I'm a little bit like that at times. You're not comfortable with it. You just can't afford it. What are some things you can do? And I always, tell people that just you can take a Google map image, a Google Earth image, and create a map of various portions of your facility, and actually use those maps to take, no time. And most of you probably already do that. And you can gain a lot of insight on your facility just by doing that. I like to talk to people about, mapping, your weed control, disease control efforts to really understand whether or not you're gaining any ground on controlling various pests that you have on your facility. You can do the same thing with a lot of the stuff we do as well. So, to dumb it down again, just, taking notice of mowing patterns, cultivation practices, pest presence, all kinds of things that are going on in the field that you want to denote, and then really see, what the impact is. I get tons of guys that ask me questions about weed control, and they sprayed X chemical on their yellow nutsedge, and it didn't work, but then they go back the next year and spray the same chemistry. So kind of noting what you're doing and what the outcome is obviously going to help everybody. So again, knowing the most you can about your site is going to allow you to make all kinds of decisions, whether it's irrigation-based, wetting agent applications, pesticides, PGRs, various other things here. So that boils down to, what do you do with this information? And that's probably been the greatest challenge for us, taking so much of this data, and for all the companies that generate a lot of this data, is really, what do you do? How do you package this and sell it to somebody, or how do you direct someone, to take their data and do X, Y, and Z with it? So what can you do with some of this stuff? And we're just going to go through a couple of examples, but it really boils down to utilizing what we refer to as precision turfgrass management. So starting to manage your field at a smaller scale and applying things only sort of where needed, when needed, and the amount needed. And really, fostering more precise, efficient applications of your inputs. And this frees up a lot of your budget to do other things, especially when you get to levels where, you can't afford to do a whole lot. You can't afford to make any mistakes. If you can free up some money in your pest budget to do, more cultivation events or vice versa, that can help you, get a better product out there. So what are some of the examples? So when we go out and we map a facility, this is actually on campus at UGA. These fields get a whole lot of activity, sometimes more than we like. We can go out, we can map for soil compaction, and then we can take the data and we can identify site-specific management units that we have identified as either low, moderate, or high when it comes to the respective soil compaction, and then come in and actually either leave certain areas alone that we feel don't need aerification practices, and then focus on others. And again, this is going to vary based on the facility you have. If you have a typical football field where you're only running football, you're going to have, everybody knows you're going to have more issues with the center of the field versus, some of the outer portions. But when you get into fields like this that are multi-sport use, and they're flipping the field and doing all kinds of other things, you don't really know what's going on half the time. Beneath the surface. So we've done a lot of site-specific cultivation studies where we've looked at trying to implement some of these site-specific management practices and then trying to figure out, does this work? If you site-specifically aerify areas, what we do is we come in and we take samples to get a baseline of the situation. You can see there's areas on this field. This is a pre-high school. I guess this is predominantly, high school plays a little bit on this, and then community sports type scenario. You can see there's imperfections in the field. You can see open areas of turf. So these fields get a lot of use. So we come in, we get general information on what the background is in soil compaction and various other characteristics. We can load a lot of this data into some of our devices, and we can predict what the upper quartile or the top 25% of this specific plot is with respect to surface hardness or soil compaction. And we know that that's the area of that plot or an area of the field that needs the most help. So we can come in and actually site-specifically aerify, and again, it's not going to be that jagged. You're not going to be that exact. But you can focus in that area more of your aerification practices and focus less in the other areas, which are the lower 75%, and try to increase more or less the uniformity of that situation. And we do all this stuff through GPS maps, which allow us to come in and actually aerify those locations. And then really just monitoring how does that affect the soil compaction of that site. You know, you have an inner portion of that plot, you know, 1 year, and you site specifically aerified the center portion of that plot. And then what does it look like the next year? Are you making an impact? You're never going to have this thing be one color. You're not going to have complete uniformity, homogeneity, but you can decrease the fact that you have, you know, a lower or an issue, a higher issue of soil compaction in the center of that specific plot. New spray technology. We started working with a lot of new spray technology this past year. This is one example. Various other companies, Toro and various other companies, have similar devices. There's some differences in a few things, but for the most part, there's a lot of similarity. This is specifically the Smithco Star Command system. It has the capstan sharpshooter on it, Raven technology for GPS. It's got multiple nozzles at each station, which allows us to do variable rates. It also allows the device to go at various speeds. So when we use this device, flat out say, Chase and I are probably the worst sprayers on the planet. We're fluctuating from 2 miles an hour. We're not trying to get to 10, but we're at 2 to 6. You know, we're just not that great at it. This allows you to actually spray at the same rate if you're going 2 versus 6 miles an hour. It takes that factor out of having a person that you just trained that just isn't a really good sprayer. You can adjust applications any rate above 0.4 gallons per thousand. You maintain proper flow and pressure throughout the whole thing. It's also GPS guided, so all the nozzles are independent, so it'll turn on and off. You no longer can turn around and overlap a pass. It will turn those nozzles off, and it will not spray that area. And it records all these maps, and we'll kind of go briefly into this here towards the end of the presentation. But so you can load maps that you generate. So if you went out here and you took a field, you had a handheld soil moisture meter, and you generated a soil moisture map, and then you came in and you figured out where your areas you wanted to focus on, you could load this map into the sprayer, and it could site-specifically spray a wetting agent if you had issues with localized dry spot. Or you could use these maps again to determine how you wanted to irrigate your field or how you wanted to come in and maybe syringe by hand. This is an example that we've been working on is weed control. So you can come in here, and a lot of times it's really easy to see issues with weeds during the winter in the south when you have dormant Bermuda grass. You know, you may have lots of weed pressure, and guys will come out and they'll spray wall to wall Roundup. There's no need to do that. You can literally come out here with the sprayer. You can ride around the sprayer, and you can start to circle areas with the sprayer that you want to spray. And then there may be other parts of the field that have no weeds, so why spray them? And you start to generate polygons of areas that you want the sprayer to spray. You come back in and you can delineate your fields, so you can actually go to the corners of the fields and you can create a map of these fields showing, okay, here's the total area, here's the area I'm focusing on. And then you come in, and what you do is you actually, for the whole area, you can create what's called a no spray zone. So the whole time you're in that no spray zone, it's not going to spray until it hits an area that you tell the sprayer, hey, this is what I want to spray, and then it'll turn on and off. Once you create these regions, obviously for sports turf, it's not going to be the same region all the time, but if you're like a golf course superintendent, once you circle your greens, I mean, you could have Joe Schmo that just started today go out there on the sprayer, as long as he doesn't drive in the pond, and it'll just turn on and off. You can turn it on when they leave the facility, and it'll only turn on and off once it hits those regions. It's not going to turn on any other time. So what happens is you go back and forth like you're typically spraying on these areas, and you can see these little yellow sort of tiny little squares on here, and those are small little areas that the sprayer generates what your output and application rate is and your coverage, and it'll actually, so on the right side there, you can see it'll go through each one of those little squares, and your target is set, and then it'll tell you where you are with respect to that rate. And this isn't perfect, and Chase and I, again, are crappy sprayers. So you can see our pattern's not too great either. No, we might have had an issue on the upper left corner. But again, I mean, it gives you a lot of information as far as what you're spraying, how much you're spraying, and, you know, how much you're saving and things like that. All right, that's my last slide. We've also done a lot with, we're moving into drone technology. We understand the fact that a lot of these mobile devices, and for that matter, some of these handheld devices are hard to use a lot. So we're really trying now to incorporate drones into the mix. And, you know, if you can fly a drone every day and generate quick and dirty information about your fields, can you apply that data to some of the handheld or mobile devices maybe you're running every 2 weeks or a month? And how does that data jive with one another? Can you use some of these maps? So this is an example, upper right corner of estimated ET. So we have a thermal heat device that's on the drone. You come out and you can see there's some, if this pointer would work, the shade from the building here in the lower left corner of that map, it is basically eliminating, you know, the heat signature. And then there's a little dot in the center where you have this weird pattern. There's a fan there because the athletics group was trying to dry the sod there prior to practice because they laid some new sod. You can see the effect of the fan on the heat signature coming off that field. So it's kind of neat too. But so we try, so you can take this data, look at local ET rates depending upon the grass you have, and you can actually come up with a map that shows what the estimated ET is, and you can come up with a situation where you know on the field, okay, here's some hot spots I need to come out and syringe. You may have known that beforehand, maybe you haven't. We get a lot of issues where hot spots come up based on new sod that's laid. We deal a lot with UGA athletics where they may turn over sod quite often just simply because that's what they desire, and new issues arise because of that. But this allows you to focus some of your efforts again, and this could also be downloaded into some of these variable rate sprayers, and you can come up with some things as far as variable rate technology applications as well.